Welcome back, friends. This is Dr. Mlelwa Lecturers. Don't forget to click the subscribe button and to click the bell. Then put all for more updates. To join our Telegram group for discussions, just click show more in the description. Then if you scroll down, you'll see the links for the O-level and the A-level group. Welcome back, friends. This is Dr. Mlelwa Lecturers, and we are continuing with our topic of status of matter. In this session, we are going to look about the association of gases. The facilitator, I am Dr. Mlelwa. If you remember, in the previous session, we looked about the dissociation of gases. And as we said that the degree of dissociation can be calculated as Vantage Factor minus 1 divided by number of particles minus 1. This was the formula for calculating the degree of dissociation. Now, in this session, we are going to continue discussing about the concept of association of gases and calculating the degree of association of gases. Now, what you are saying is that association is just like the inverse of dissociation. In dissociation, we had one particle dissociate or break down to form many particles. In association, many particles they join to form one larger particle. So association is the combination of more than one smaller particles to form one larger particles. Combination of more than one smaller particles to form larger particles. So association lead to decrease in number of particles, so that the observed number of particles is smaller than expected. Now, tuangalie tu concept rahisi hapo. We say the molar mass is inversely proportional to number of particles, and we called this equation 1 kwenye session zilizopita. Kwa kama unafuatilia vipindi session zilizopita, tuliderive hichi kitu kinatokea wapi from the Dimerization equation. Now, if association leads to number of particles iwe small, so observe the number of particles in association, observe the number of particles in association will be smaller. Observed number of particles will be smaller as compared to the expected number of particles. So simply ni kwamba kwenye association molar mass iwe inafanyaje? Inaongezeka. Molar mass inaongezeka. Kwenye association molar mass inaongezeka. Kwa sababu tunapokuwa tunapunguza particle, tuna decrease volume, hence molar mass inaongezeka. So this is inverse to dissociation. Dissociation molar mass inaongezeka, association molar mass dissociation molar mass inapungua. Association molar mass inaongezeka. So take an example. Hii hapa ni aluminium chloride. This has the ability to associate kwenda kutengeneza aluminium 2 chlorine 6. Kwa kama ambavyo unaweza kaona hapo kwamba tuna 2 molecules zimecombine kwenda kuform 1 molecule, and molar mass of this molecule is greater as compared to this. So in dissociation molar mass inafanyaje? Inapungua, kwenye association inaongezeka. Dissociation inapungua, association inaongezeka. So decrease in number of particles lead to decrease in volume, and from the ideal gas equation as how we derived in the previous sessions, kwamba a decrease in the number of particles will lead to increase in molar mass, kama ambavyo tu derive kwenye previous sessions. So as the volume of the gas decreases, the molar mass of the gas increases. So therefore association makes the measured molar volume to be greater than expected, as the molecular formula suggests. So the degree of association, still the formula remains the same. Degree of association is equal to number of gas molecules associated divided by number of gas molecules before dissociation. Before dissociation. So simply that's how we calculate the degree of association. The symbol used is also alpha. So tunatumia alama ile lakini the formula they are different. So now let's see the example of association here. Association of aluminium chloride in vapor. So aluminium chloride ikiwa kwenye vapor, yani ikiwa kwenye hali ya mvuke, kwenye vapor phase. Tutaenda kuona huko mbele kuhusu liquid phase, solid phase pamoja na vapor phase. Ni kama vile tu kwenye states ambapo na solid state, gaseous state pamoja na liquid state. Also we have the phases. So in a vapor phase, two molecules of aluminium chloride associate or they dimerize. We call it as dimerization. Tukiwa tuna molecule mbili zinaungana pamoja kutengeneza one molecule, tunaita dimerization. So the process of dimerization of aluminium chloride makes its observed molar greater than expected. So for example, tukiwa tuna 2 aluminium chloride, yule pale huyo hapa dimerize anaenda kuform aluminium 2 chlorine 6. So this is the dimerized molecule of aluminium chloride. The process which takes place here we call it dimerize. We call it as dimerize. So kama tukawa na aluminium chloride, let's say tukaichora kama aluminium chloride. Hii aluminium chloride ikidimerize inakuwa kama aluminium moja hapa, aluminium moja nyingine pale. So zikidimerize pale tunakuwa na chlorine, pale tunakuwa tuna chlorine, pale tunakuwa na chlorine, tuna chlorine mwingine pale na chlorine mwingine pale. So this is the structure of the dimerized molecule of aluminium. Kama unaweza kuona chlorine 1 2 3 4 5 6 and then we have 2 aluminiums. So aluminium 2 chlorine 6, dimerized molecule of aluminium chloride. Kwa hiyo kiufupi aluminium chloride in the vapor phase can dimerize. So now tuangalie jinsi gani ambavyo tunaweza calculate the degree of association of gases. So now in this concept tuna let n iwe number of particles before association. Kule kwenye dissociation to let n iwe number of particles after association. So now let n tuna let n iwe total number of particles before dissociation. Before association, sorry. Very sorry. This is before association. So now to let kwamba tuna molecule fulani. So we have number of particles n of a certain molecule, and this molecule is A, X, B, Y. Now this number of particles n, they associate, and after this association they will form A, X, N, then B, Y, N. So for example hapo unaweza kaelewa tu kwamba kwa mfano tulivyotengeneza tulivyokuwa tuna 2 molecules of aluminium chloride 3. Hizi hapa zilivyo associate zikatengeneza nini? Maana yake 2 ikahamia hapa. Unaona hii n itahamia hapa. Unaona? So 2 ndo hii n itahamia hapa, itakuja kwa nini? AXN. So itakuwa aluminium, X ndio ilikuwa ngapi? Kwa hapa ni 1. X is 1 here. So 2 itahamia hapa. Unaona? Then chlorine YN. Y hapa ni ngapi? Ni 3. N it's 2. So inakuwa ngapi? 6. So that's the concept ambayo inatumika hapa. So we have the N A X B Y, then associate to form A X N B Y N. But in association we must form one molecule. So we have the N molecule here, then here we have 0 before association. After association we have N minus a degree of association. Degree of association, which we don't know it is. So it is N, actually it is N minus, it is any particle, then 1 minus
Kwa katika kila number of particle n, katika kila mmoja amepungua ile pale. Kwa sababu actually ni kwamba particles n hazijulikani ni ngapi. Kwa hiyo tuwezi kuchukua, tuna types na n ili katika kila particle mmoja awe ampungua degree of dissociation. And then huku tutakuwa na nini? Tutakuwa na degree of dissociation yule pale ametengenezwa. Tutakuwa na degree of dissociation. So now Vantage Factor, kwanza tuangalie expected number of particles. Expected number of particles itakuwa ngapi? N. Hii hapa expected number of particles. Observed number of particles, observed number of particles itakuwa sana n yule pale, then n minus degree of this, I mean 1, then plus. So ukiangalia hapo vizuri itakuwa ni n 1 minus degree of dissociation plus degree of dissociation. So actually ni kama tunaweza kuiacha hivyo hivyo, inaweza kabaki hivyo hivyo. Now let's come to the concept of Vantage Factor again, and then we are saying the Vantage Factor is equal to observed number of particles, observed divided by expected. So Vantage Factor I will be equal to observed, that is n 1 minus z plus, then we divide by expected n. So actually Vantage Factor hapa tunatakiwa to make subject the degree of dissociation. So it will be n minus any degree of dissociation plus c degree of dissociation divided by n. So Vantage Factor will be equal to it will be n plus degree of dissociation minus any degree of dissociation divided by n. So its Vantage Factor is equal to n plus 1 minus any degree of dissociation divided by n. So Vantage Factor n is equal to n plus 1 minus any degree of dissociation. Tunakakua degree of dissociation hapo, degree of dissociation. So itakuwa ni Vantage Factor n is equal to n plus 1 minus any degree of dissociation. So degree of Vantage Factor n minus n will be equal to 1 plus 1 minus any degree of dissociation. So it is Vantage Factor n minus n divided by 1 minus n is equal to degree of it is association. So degree of association is equal to Vantage Factor n minus n divided by 1 minus n. So degree of association, not dissociation. Association is equal to Vantage Factor minus 1, then you kutapata n outside 1 minus n. Hiyo ndio degree of association. Kwa hiyo unaweza ukatimes na hii factor 1 divided by n, ukatimes hapo. Times huku utakuja kupata degree of dissociation, association is equal to Vantage Factor minus 1, then ukichini utapata 1 divided by n, 1 divided by n minus 1. So either hii equation au hii equation. Hizo ndio equation mbili za kutafuta degree of association. Association, not dissociation, association. Kwa hiyo ambapo unaweza kaona derivation ndefu kidogo, lakini tumekuja kuishia pale kwamba degree of association is equal to pale. So Vantage Factor na vinginevyo tutaenda kuona tu kwa mbele, lakini kifupi tu ni kwamba lazima unajua kuhusu hizo concept za kucalculate degree of association pamoja na degree of dissociation. So we have few things to note here. For association, Vantage Factor is less than 1 because of the number of particles must be less than expected. Kwa kwenye association Vantage factor inakuwa less than 1. Wakati kwenye dissociation Vantage factor is greater than 1. If Vantage factor is equal to 1, there is neither association nor dissociation. So Vantage factor kwenye association is less than 1, while kwenye dissociation is greater than 1. Hiyo ni kwa sababu ya calculation yenyewe ya formula ya Vantage factor. Kwa hiyo observed number of particles divided by expected. Hiyo ni moja kati ya njia. We have 4 ways of calculating the Vantage factor. We have 4 different formulas of calculating Vantage factor. Formula ya pili inasema observed, formula ya pili ni observed or measured volume divided by expected volume. Unaona? Kwenye volume pia tunaanza nini? Na observed gawanya kwa expected. Kwa sababu gani? Because volume is that proportional to the number of particles. Lakini kwenye molar mass tunaanza na expected. Molar mass tunaanza na expected molar mass gawanya kwa observed molar mass. Lakini kwenye pressure pia tunaanza na observed gawanya kwa expected. Kwa sababu pressure is the proportional to the number of particles. Kwa hiyo tunachokiangalia simply ni relationship kati ya hiyo parameter tunayoitumia pamoja na nani? Na number of particles. Kwenye number of particles zenyewe tunatumia observed expected. Volume observed expected. Molar mass ni expected observed. Ni tuna reverse. Kwa nini? Kwa sababu the relationship between the molar mass and number of particles is inverse proportional. Pressure observed expected kwa sababu it is direct proportional to the number of particles. So we have the example here. We have the example, but we will solve it. We will discuss it in next sessions. So in this session, let it end up here. Don't forget to share the link for the video and to subscribe the channel. So thank you.